All right, let's check this one out. In a research experiment, a population of fruit flies is increasing according to a law of exponential growth. Ooh. I know exponential growth. You guys remember exponential growth? Do you know exponential growth? Y equals A, and then we have B raised to the, no, that's not right, times E raised to the BT. So this is exponential growth. So we're going to use this guy. All right. So after 2 days, there are 100 flies. After 4 days, there are 300 flies. If we were making a little chart right here, in days, we have 2 days, we have 100 flies. This is number of flies. So in this case, I want to just say Y. And then after 4 days, there were 300 flies. That's great. How many flies will there be after 5 days? Well, this kind of stinks because I don't have anything to plug 5 into. If I plug 5 into this, I'm not going to get an answer. So we must find the A and the B. If we find the A and the B, then we can plug in 5, and then we will get an answer. So looks like we have a job to do. We have to find that A and that B. How are we going to do that? Well, we need to have some values for the T and the Y. Do we have T and Y values? Yeah. Oh, heck yeah. Check this out. We have 100 equals A, E raised to the 2, B times 2. Right? It's BT. So 2 is my T. All right, so I have 2B. The other one I have is 300 equals A, E to the 2, no, not 2, 4B. Oh, snap. Look at this. We have a system of exponential equations. Oh, didn't think you'd ever do that, huh? So what we're going to do is we're going to solve for one of the variables, and we're going to take that, whatever it equals, and plug it into the other equation. Let's solve for A. I mean, we could solve for B. What do you guys want to solve for?
A.
Oh, it's half and half. Should we do B?
Yeah.
If we do B, we're going to have natural logs.
Yeah.
Huh? Okay, let's do that. All right, we'll solve for B. Okay, so I have 100 equals A, E to the 2B, and I'm going to divide both sides by A. And then how do I get rid of this E so that I can get the B out of there? I got a natural log both sides. So that's an A. Sorry, my A's sometimes look like 9s. I have natural log of that. And then this E is gone. Oh, snap. So I have 2B equals that. How do I get the B alone? Divide by 2. Okay, so this is what B equals. B equals natural log of 100 divided by A divided by 2. So that's what B equals. And that was with this first equation. So that means I'm going to take this other equation and I'm going to plug B into it. So I have 300 equals A, E to the 4 times, oh man, this is hideous, times natural log of 100 divided by A divided by A. Right?
2.
No, 2. It was 2. Okay, divided by 2. So if I multiply those, that 4 goes away, that 2 goes away, the 4 becomes a 2, and it's right next to that natural log. Okay. Why? No, the A is not gone. It's underneath the 100. So I have an A here and an A here. Okay, so what would be our next move? Our next move would be to get rid of this exponent so I can get to this A somehow. Oh, snap. You see that? There's an E and a natural log. I think this way might be a little harder. I think it was easier to solve for A first because I did that with my other class. But this 2, I'm going to rewrite as an exponent of the inside. Let me rewrite it because it looks kind of nasty. 300 equals A, E raised to the natural log of 100 divided by A raised to the second power. You know why I did that? This is why I did that. Peace out. Those go away. They undo each other. E raised to the natural log, those are opposites. Oh, that's very nice. Okay, so now we have 300 equals A times 10,000 over A squared. Yeah, I did the power. I went ahead and did the power. I went 100 times 100 and A times A to get 10,000 over A squared. And what's going to happen when I multiply this by A? Shki. Okay, cool, yeah. Multiply both sides by A. Now I have 300. A equals 10,000. And then I divide both sides by 300. I get A equals What was that? Divide by 300. Cancel out these zeros right here. Divide the top and bottom by 100. So we got 100 divided by 3 is A. Oh, hideous. Okay, so if that's what A is, how are we going to find out what B is?
Yeah, you did. Just plug it in.
Plug it in. Okay, let's find out what B is. All right, so B equals natural log of 100 divided by 100 divided by 3 divided by 2. Oh, man, how's that going to happen? Oh, I know. All right, here, check this out. Whenever we have fractions inside of fractions, so some of us always go brain dead here. So if I had 100 divided by 100 over 3, that's the same as 100 times 3 over 100, which would have the hundreds cancel out, and you're left with 3. So all this junk right in here just equals 3. So B equals natural log of 3 divided by 2. So do we have a function now? Do we have the A and the B?
Yeah.
For show. Our B is nasty looking, natural log of 3 over 2. And the A is 100 over 3. All right, we got our model. Woo! Now can I take this 5 and plug it in a T?
Yes.
I know you guys were excited about that. Yeah, you were. Put the 5 into that T. Let's rewrite it so it looks pretty. We have Y equals 100 divided by 3. E raised to the 5 natural log of 3 divided by 2. Oh, man, I could barely see this dude. All right, can you guys plug this into your calculator and see what you get? Because that's going to give us our answer. So we get 519, whoops, 0.615. Oh my goodness, that is a hideous answer. What is that, flies? Flies. All right.